What if I told you that Tesla just built a plane that could end flight delays forever? One that doesn't need fuel, barely needs maintenance, and could take off straight from your hometown airport. Sounds impossible, right? But this time it's real. Have you ever been delayed at the airport for hours because of unexpected maintenance? Or maybe you've paid a sky-high fare only to find out your flight's been canceled anyway. What about those times you had to drive all the way to a major city because your local airport couldn't keep a single plane operational? Well, the 2026 Tesla super electric plane aims to end those headaches for good. This isn't just another electric prototype. It's a complete rethinking of how aircraft are built, maintained, and operated. Tesla's goal here is bold: shorten hangar time, cut operating costs per flight hour, reduce dependence on specialized maintenance crews, and bring routes back to small regional airports, the ones closer to your home. So what's truly shocking here? Could on-time schedules finally become the default instead of a miracle? Could fares actually drop while reliability goes up? And could you finally skip the massive hubs and fly straight from your hometown airport? But here's where things take a wild turn. Because the secret behind Tesla's aviation breakthrough isn't in its battery. It's in how it thinks about maintenance itself. Today, we're diving deep into the operational heart of the 2026 Tesla super electric plane to uncover exactly how it slashes maintenance time, reduces costs, and changes the economics of air travel forever. Modular electric propulsion, the quick swap revolution. At the core of Tesla's aviation breakthrough is a concept borrowed from its automotive DNA: modular electric propulsion pods. Each pod is a self-contained system that includes the electric motor, inverter, and electric propeller, along with standardized connectors for power, data, cooling, and structure. When a pod detects a fault, the aircraft doesn't sit idle for days waiting for technicians to disassemble half the engine. Instead, a team of just 4 technicians can remove the entire faulty pod and install a standardized replacement in just 4 to 8 hours. Once that's done, they perform a propeller balance and a ground test run lasting 30 to 60 minutes. Compare that to conventional turboprop maintenance, where opening a turbine for inspection alone can take 3 to 10 days. That's the first major leap: hours instead of days. It's the difference between canceling multiple flights and simply rescheduling the next departure later the same day. But wait, that's only the surface. Because Tesla didn't just make maintenance faster, they made it predictable. And what that means for airlines will blow your mind. Cutting maintenance hours and boosting reliability. Traditional turboprop aircraft typically require 4 to 6 maintenance man-hours for every flight hour, just for the engines alone. Tesla's modular design changes that completely. With no combustor, no oil system, and no large gearbox, the Tesla super electric plane brings this figure down to just 1 to 2 man-hours per flight hour, a 50 to 75% reduction. Because each propulsion module is pre-tested, pre-balanced, and certified at Tesla's central facilities, on-site work becomes far more predictable. This design also reduces AOG, aircraft on ground situations, by 30 to 50%, and pushes on-time performance up by 5 to 10 percentage points, meaning a shift from 78% on time to as high as 88%. That translates directly into fewer rebookings, fewer hotel vouchers, and a smoother overall experience for passengers. But what if I told you these time savings don't just make flights cheaper, they could actually bring dead airports back to life? Turning maintenance savings into lower fares. Let's talk about the numbers. For short-haul routes, power plant maintenance can make up 20 to 30% of total operating costs. By cutting labor hours and hangar downtime, Tesla's new design could reduce cost per seat kilometer by 15 to 25%. Here's what that means in practice. On a 300-kilometer route with 19 passengers and an average cost of $0.20 per seat kilometer, the total operating cost is around $1,140. The Tesla superelectric plane can save $200 to $250 per leg. Enough margin to soften fares without touching reliability. It's simple math that could change regional aviation economics entirely. But how does Tesla guarantee that swapping these high-voltage systems stays safe, even under pressure? The answer is in their next-level precision engineering. Precision, safety, and verification built in. Every maintenance swap follows a rigorous verification checklist. Technicians measure high-voltage insulation resistance, pressure test cooling systems, balance the propeller dynamically, and perform multi-level power checks for 30 to 60 minutes. An optional 10 to 15-minute technical flight confirms everything before passenger service resumes. Each pod's serial number, inverter firmware, and test results are logged digitally into Tesla's aircraft database, a system proven to reduce repeat issues by up to 30%. By keeping one spare propulsion pod for every 3 aircraft in the fleet, operators can cover over 95% of single-event faults without delay. That's how Tesla turns a week-long hangar job into a one-day turnaround, improving efficiency, reliability, and schedule stability across the board. And that's not all, because Tesla's next innovation takes the less is more idea to a level aviation has never seen before. Fewer moving parts, fewer problems. There's a reason electric vehicles outlast combustion engines: simplicity. The Tesla superelectric plane follows that same philosophy. Each electric motor has just a rotor and a few bearings, no pistons, valves, turbos, or gearboxes. That means fewer potential points of failure and dramatically lower maintenance demand. Older turboprop engines can eat up 4 to 6 man-hours of maintenance for every flight hour. But the Tesla system brings that down to just 1 or 2. For passengers, this translates into fewer "please wait for maintenance" announcements and more consistent on-time performance month after month. But what happens when Tesla applies car-style innovation, like regenerative braking, to a plane? The result is something truly unexpected. Goodbye to complex fuel and oil systems. By removing entire systems like fuel pumps, pressure lines, oil filters, and combustors, Tesla eliminates dozens of recurring maintenance tasks. No more oil changes. No more fuel leak checks. No more turbine blade inspections or soot cleaning. The result? 30 to 40% fewer A and B maintenance checks per year, faster turnarounds, and less ground time per aircraft. Regional operators can schedule more flights per day while still maintaining higher reliability. Regenerative braking. Small detail, big impact. During taxiing and landing, the plane's electric motors switch to generator mode, capturing kinetic energy to recharge the battery. This reduces wear on mechanical brakes and landing gear by 20 to 30%, extending replacement intervals by up to 40%. For aircraft that perform hundreds of short routes a month, this adds up to thousands of dollars saved annually in parts and labor, plus less downtime. But here's where the real magic begins. Tesla's next feature doesn't just predict problems. It prevents them before they ever happen. Predictive maintenance and OTAA updates. Each propulsion pod is loaded with sensors measuring vibration, temperature, current, voltage, pressure, and coolant flow. These sensors collect and transmit up to 5 megabytes of data per minute during flight, feeding Tesla's AI-based fleet cloud. If the system detects even a small anomaly, say a 0.2 G vibration increase or a 10-degree C rise in bearing temperature, it automatically schedules that pod for replacement long before failure. That's predictive maintenance in action. And, just when you think that's futuristic enough, Tesla adds something that no other aircraft on Earth can do. Over-the-air aviation updates, the power of OTAA, over-the-air aviation updates. Every inverter, battery management system, and flight computer receives regular OTAA updates over secure channels. These updates fix software bugs, optimize power usage, improve torque mapping, and even fine-tune cooling behavior for different climates, all without sending the plane to a maintenance hangar. Shop visits for minor software tweaks can drop by up to 90%, saving 2 to 4 hours of downtime per incident and thousands in costs per year. But while most airlines struggle with parts shortages, Tesla's secret weapon is waiting quietly inside its gigafactories, ready to flip the entire industry upside down. Gigafactory-style standardized parts supply. Borrowing from its gigafactory philosophy, Tesla has created a standardized parts ecosystem for aviation. Older aircraft often have 7,000, 8,000 unique parts for the power and electrical systems alone. Tesla's new architecture brings that down to about 2,500 standardized parts. This simplification allows airports to stock essential components in modular kits, covering 95% of quick repairs without waiting for manufacturer orders, from 20 days to 72 hours. Tesla's logistics speed is rewriting aviation's rulebook. But after all these breakthroughs, the biggest shock isn't about technology or cost. It's about what this means for you, the passenger. The real shock: time, money, and convenience. Imagine this: no week-long maintenance delays. No flights canceled because of parts shortages. No overpriced fares just to cover turbine overhaul costs. Instead, same-day turnarounds, predictive diagnostics, smart updates, and standardized logistics. This aircraft represents the same leap forward for aviation that the Model S did for cars. It's not about luxury, it's about efficiency, reliability, and accessibility. The Tesla super electric plane promises less waiting, thanks to 4 8-hour modular swaps, lower fares, through 15-25% operating cost reductions, more on-time flights, with predictive monitoring and OTA-closer airports as small airfields become viable again. But here's the real question. When this aircraft finally takes off, will it just change aviation, or will it redefine how the world travels forever? Finally, so which benefit of the 2026 Tesla super electric plane impresses you the most? Is it A, shorter maintenance time, B, lower fares, C, more on-time flights, D, the return of local airports? Drop your choice in the comments below. A, B, C, or D, and tell us what you think about Tesla's latest leap in transportation. If you value technology that genuinely makes life simpler, smarter, and more efficient, make sure to subscribe to Road Zone Reviews and turn on the notification bell so you never miss an update. Because here, we don't just talk about innovation, we show you how it's rewriting the future of travel.